Hi friends, welcome to our channel. Let's have a look at problem 3537. Fill a special grid. In this video, we're going to solve this problem using recursion plus copy. So here, recursion is the key, but the copy is just a choice, right? You can choose to use copy, or you can choose not to use it. So basically, we give an integer n representing a 2 to the power n times 2 to the power n grid. Then we must fill the grid with integers from 0 to this number minus 1 to make it special. A grid is special is defined by this 4 items. So basically, it means that if you draw it, this is the smallest one, and this one is the second smallest one. This one is the third smallest one, and this 3 is the smallest one. And then if you look at here, so this is from 2. If you have 2, so the size will be 4 times 4, right? Originally n equals 1, the size is 2 by 2. So here actually this block here is actually, if you add 4 is the size of itself, so you will get this one, right? And then this one, and you add 4 again, that is the size, so the number of cells, right? So you get this one, and then you get 4 again, you get this one. Then you just need to concatenate the corresponding blocks. So this is what we are going to do, right? So first I'm going to write some special case. If n equals 0, right? So the size will be 2 to the power 1 minus 1, that is 1, right? So we just need to return this one. That is 0. So notice that, so it's a list of lists, right? So if n equals 1, right? So we need to return this one. It should be 3 0, right? And 2 1. And then if for general n we want to use recursion, first I'm going to make a self call. That is, let me directly copy this one. You get n minus 1. Then from this block, you want to construct all the other blocks. So here you can regard this one as, you can see this is the quadrant 0, this is quadrant 4, this is a quadratic 3, this is 2, right? So you can this is the quadratic 1, right? So now you want to construct, so we can construct the other quadrant. So here first I want to get the size of this guy. So this guy, the size actually is 2 to the power n minus 1 times 2 to the power n minus 1, right? So but I don't care, because we don't want to use this one. You can do the size, or the number of cells in the current will be the length of current square, right? So this is always right? So then or you can just write the length of this. So the length will be length of current. So what you're going to do, and also let's get the size. It's just a square. So I'm writing this one is just for the ease of iteration. So now I want to initialize the blocks. So block 4, so corresponding to quadrant 4, right? That will be a copy of the current, but you cannot use this. If you use this, it's still the inner cells are modified. If you modify block 4, then the elements in current will be modified. So the correct way to do this will be item copy for item in current. So this is the right way. So this is also a key point for using copy. For multi array, right? Multi-dimension array. So here the point is that array, a list is mutable, right? So notice this is especially important. It's very important, I would say. So once you have this, so you can also do initialize some other 2 blocks. Let's see, copy this one, block 3, block 2. So this corresponds to the quadrant 4, 3, 2. So this corresponding to quadrant 1, right? So now what do we do? So we just add the size to block 1, block 4. Then add the double set to block 3 and the triple set to this one. So what we do is this: for I in range length, so for j in range length. So what we do is block 4 ij is incremented by size, and block 3 ij is incremented by 2 times size, right? Then block 2 ij is incremented by 3 times size, right? And then you get the 4 blocks. So you can see the 4 block is like this is 2. Let me write like this. So this is 2, this is the 1, this is the 4, this is the 3. Let me copy this here. Right. And then what I want to do is just to align 2 and 1, align 4 and 3. So this is rather simple to do, right? So we have a result. Then I'm going to do this for AB in zip. So block 2, right? Block 2 and block 1. Block 1 is current, right? And then what we do, we just concatenate, because this A and B are 2 lists, right? So we just result append A plus B, right? And then similarly, we do for AB in zip block 3 and block 4. Then we result append A plus B. And then we can return the result state. So this will be a full code. I'm writing it with full details so that you know the method process. So let me run it. Yeah, it passes the 3 cases. So 1, 2 is special, but 3 is the one that begins to using recursive call. So let's submit that. Yeah, and it passes all the cases. So here, let me emphasize again. From here up to this, so actually we call the one for previous n-1, and then this part is construct the result for n equals n from n equals 1. So notice that so if for n equals 1, so the size actually is this: 2 to the power n-1 times 2 to the power n-1, right? So for n, right, so it's 2 to the power n times 2 to the power n. Actually, so let's call this f n-1 and call this one f n, right? So you see fn divided by fn-1 actually is 4, right? Because here 2 to the power n divided by this one, you get 2, and this you get another 2. That's why we need 4 blocks of the previous result to get the current result. So here, this itself, the previous result is 1 block. Then you add the size of it itself, you get another block, you get another block, you get another block. But here we do it in a clockwise fashion, right? From the first quadrant to the fourth, to the third, to the second, right? That's why the code like this. And then we zip and concatenate them and form the final result. So that will be the full thought process. So with that said, I guess that's it for the current video. So we have a YouTube channel which contains more than 1,000 very careful and rigorous videos for leetcode problem. You are welcome to check out those videos for some practices. With that said, thank you for watching.